Computational thinking is a problem-solving process that is involved in formulating a problem and expressing its solutions in a logical and analytic way. An example of this way of thinking would be using step-by-step instructions or algorithms to effectively carry out the problem. While computational thinking is essential for computer programming, it is also beneficial for learning because it encourages problem-solving strategies. It is especially beneficial in supporting problem-solving in math and science. There are a few different ways computational thinking can be used in a classroom. The first is by breaking a problem into parts or steps, or decomposition. For example, in an English classroom, you could break a poem into rhyme, meter, diction, and imagery to help you understand the meaning. Another way to use computational thinking is to look for patterns or trends that help you understand the data. In an economics or history class, you might study trends of a country's gross domestic product to see if you can predict where it might be going next. Computational thinking also helps students develop instructions or steps to complete a task. For example, a home economics class might have a project where the students are required to create a recipe and carry it out. Lastly, students can learn to generalize patterns, rules, or principles in order to complete a task. A geometry class might have a problem where they are given the beginning and end of a proof and need to use general patterns to figure out the sequence. The ISTE standards for teachers show the importance of computational thinking in classroom learning by stressing the importance of modeling digital age work. Standard 3 of the ISTE standards for teachers says that teachers should exhibit knowledge, skills, and work processes that represent the professional digital society. The ISTE standard for students put a greater emphasis on computational thinking by having two separate standards relating to it. Students should be knowledge constructors by using a variety of resources to make meaningful experiences for themselves, but also computational thinkers by employing strategies for problem solving and understanding. The new South Carolina Computer Science and Digital Literacy Standards also place emphasis on this way of thinking. A second grade standard requests that the student be able to make predictions and draw conclusions from different types of graphs. This requires that the students be able to recognize patterns in the graphs and use it to analyze the data. The third grade standard says that a student should be able to recognize that many daily tasks can be described as a step-by-step instructional sequence. This requires students to think in a logical sequence and pay attention to the steps that precede others, similar to writing code.